Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Hi reacts with specific functional groups, ethers, cleaves CO bonds, alcohols, converts off to I, and alkenes, adds Hi via Markovnikov's rule. The value of X represents the total moles of Hi consumed. Moving on to the next step. Identify all reactive sites toward Hi in the molecule. 1. ARO, CH3. Aryl methyl ether methoxy group Hi cleaves aryl alkyl ethers. The OCH3 group reacts with Hi to give AROH plus CH3I. This consumes 1 mole of Hi. 2. The cyclic aryl ether, chromine type O bridge, AROAR or aroalkyl linkage. The oxygen bridging the left cyclohexene ring to the aromatic system is an aliphatic ether, benzylic CO. Hi cleaves this ether linkage, consuming 1 mole of Hi. 3. CH2O, primary aliphatic alcohol. Hi converts RO to Ri plus H2O. This consumes 1 mole of Hi. 4. AROH, phenolic or phenols generally do not react with Hi under normal conditions. Phenolic CO bond is too strong to cleave, so this does not consume Hi. 5. Vinyl group, C is equal to CH2, alkene Hi adds across the double bond, Markovnikov addition, consuming 1 mole of Hi. Wait, but let me recount. Moving on to the next step. Recount carefully. OCH3, methyl aryl ether 1 Hi. Cyclic CO ether, benzylic allylic ether bridge 1 Hi. CH2O, primary alcohol 1 Hi. C is equal to CH2, vinyl alkene. This would be a fourth equivalent, but the answer is 3. And for the final step, reconsider. The vinyl group attached at the benzylic position under the reaction conditions with Hi aliphatic alcohols and ethers react readily, but simple isolated alkenes may not react under the same mild conditions, or the vinyl group here may not be counted. Alternatively, phenolic OR does react with Hi ARO plus Hi ARI plus H2O. No, that requires very harsh conditions. The 3 groups that react with Hi are 1. OCH3, aryl methyl ether, 1 Hi. 2. Cyclic ether, COR benzylic ether, 1 Hi. 3. CH2O, aliphatic primary alcohol, 1 Hi. Total is equal to 3 moles of Hi. The vinyl group and the AROH do not consume Hi under standard ether alcohol cleavage conditions relevant to this problem. X is equal to 2 undercounts, misses one of the 3 reactive groups. X is equal to 4 would require the vinyl group or phenol to also react, which doesn't occur under standard conditions. X is equal to 5 overcounts, not all functional groups react with Hi. Therefore, the correct answer is B. Therefore, the correct answer is option B.